Okay. By the way, I think I set the quiz to show correct answers. Are you all able to see the quiz questions and answers? Anyone? Okay, cool. Okay, so let's get started. So today we will go over U sub and area under between curves, I guess. So in Math 2A, you learn something called the differential. I mean, if you forgot, it's fine. Basically, if U is f of x, du is f prime of x dx. So we're going to make use of that by doing U sub. So U sub is a way to simplify integral. So let me just say the idea is the du part, like this du part, du gets rid of some terms inside integral. So basically, if you notice, if you let u be something and you notice that the derivative of that something is inside the integral, then you could like get rid of it. So let me just take the actual rule. So substitution rule. So this is for indefinite case. So this is just the general antiderivative. So no bounds. If u equals g of x, differentiable function whose what do you call it? Range is in interval I and f is continuous on I, then basically f of g of x times g prime of x dx is integral f of u du. Yeah, so this looks complicated, but really all you're doing is you're letting u be g of x. Then from this differential part, du is g prime of x dx, right? So this is du and this is u, yeah? So you get f of u du. So it simplifies stuff, right? Provided, you know, the derivative gets rid of some terms. So the definite case, it's pretty much the same, except you have bounds now, right? So if this is the case, right, all you're doing is you're changing your bounds. So g of a, g of x, f of u du. So again, you're letting u be g of x, du is still g prime of x dx. Now, what about the bounds? These are bounds in x variable, right? Right, because there's an x here. So when you change to bounds in u variable, right? Like it can't be the same as the x, right? You're working in u now. So you get to change it, right? So when x is a, what is u? Well, you just plug it in, right? Plug it into this thing. When x is a, u is g of a, right? When x is b, u is g of b, right? So sorry, this is not x, this is b. Yeah. Everyone clear on this? So make sure you always change bounds and know like which variable you're working in, or else you might get the wrong answer. Actually, you probably will get the wrong answer. So let me just tell you that, in this process, what is G? Let me say nobody will tell you what G is. Yeah, so it's just, practice, trial and error. Yeah, until, once you get the hang of it, you will see like where it comes up. Okay, so let's do examples then. Yeah, let's do definite examples. So integral 0 to 1. Let's start off easy. Something like this. So to simplify this, what should I let u be? I don't know how to integrate 3t minus 1 to the 50, right? But I do know how to integrate t to the 50. Do you all agree? Like t to the 50 is just t to the 51 over 51, right? So what should I let u be? Yeah. Now du, what's derivative of 3t minus 1? Well, derivative of minus 1 is 0. Derivative of 3t is 3. Yeah. So I think most students prefer it this way, so I'm gonna just do it this way. So dt is du over 3. Yeah. So let's rewrite everything, right? I have integral. Let's worry about the bounds later. So 3t minus 1 is u now. So that's u to the 50. And dt is du over 3, right? Now, what are the bounds? So when t is 0, what is u? So again, look right here. When t equals 0, what is u? Good. Now, when t is 1, what is u? Good. Yeah, so always make sure to change your bounds, yeah? And here, this is simple, right? This is 1/3, was it u to the 51 over 51 evaluated at this. And here's the nice thing, right? You don't need to move back to t coordinates, right? For the indefinite, you probably do, but here you could just evaluate it in the u bounds. So your answer is 2 to the 51, whatever this is, minus 1 over 51. Oh, no, plus, because I'm plugging in minus 1. Yeah. Yeah, so it's minus minus. So it's, minus and then negative 1 to the 51. It gives you the other minus. Okay. Everyone clear so far on this? So pretty simple. You're just simplifying the integral. Yeah. Okay. Let's continue. Let's do integral 0 to pi over 6 sine of t over cosine squared of t dt. So what should I let u be? It's like a 50-50 guess, right? If it's not sine, then it's cosine. But so what should I let u be here? It should be cosine, right? So let me just say for purposes of, trial and error, right? If you let u be sine t, du is cosine t dt. There's no cosine t dt in the integral, right? There's only a 1 over cosine dt, yeah? So you see, this will give a lot of issues, right? But if you let u be cosine, du is negative sine t dt. And we certainly have, I mean, maybe not negative sine t, but we have a sine t dt, right? So like you see it cancels, it'll get rid of the sine t dt to make the integral more doable. So I mean, I think most people prefer this though. So let's just do this. Yeah. And then from here we get integral sine t over, since u is cosine t, that's u squared, times dt from right here, it's du divided by negative sine t. Now these will cancel, right? So you get integral negative 1 over u squared du. Agree? Okay, so what are the bounds now? So when t is 0, what is u? So look right here. When t is 0, what is u? Good. Cosine of 0 is 1, right? Okay. So when t is pi over 6, what is u? Forgot your trick? Yeah, root 3 over 2, right? And the antiderivative of negative 1 over u squared, if you like, this is negative u to the negative 2. You see that this is just 1 over u, right? The antiderivative, if you work it out. So this is evaluated at 1 and root 3 over 2. So what is that? That's 2 over root 3 minus 1, right? Okay, good. Let's do some more. Let's see like 2 more and then we'll move on to area. Just so everyone is clear on how to do these. Let's do something like this. So you see, like without u sub, if you just looked at this, you wouldn't know the antiderivative, right? It's like, I mean, you see starting right now, you're already getting integrals of stuff you can't really do, just think of it right away, right? So in this case, what should I u sub? Yeah, u is ln x, du is 1 over x dx, right? That's the derivative of natural log. You can already notice that 1 over x dx is like, just this part. This part's like 1 over x dx. So, or you could just, you could also do what I did before, isolate the dx. But I think in this case, it's kind of clear. It's just 1 over root u du, right? The blue part is du, right? This part's du, and then this part's the root u. Okay, what are the bounds? So look here, right? When x is e, what is u? Yeah, ln of e is 1, right? And then what's ln of e to the 4th? Okay. Does everyone know this? Like, do you need me to explain why it's 1 and 4? Like, does everyone remember logs? I mean, it's prereq, but I have a feeling some people forgot. Okay, so you're all good with logs. Okay. So then in this case, right, this is just 1 to 4, u to the negative 1/2, right? And then you just use power rule. Use power rule. I think you get this, right? And then square root of 4 is 2. So 2 times 2 minus 2 times 1, right? I mean, 1 to any power is 1. So the answer is 2. Okay. Let's do one last one and then we will move on to area. This one's a bit harder. You will have to think about it a bit. So what should I let u be? Yeah, 1 plus square root of x, right? Like I don't know how to integrate like a sum of things to the fourth power, right? But I know how to integrate like u to the negative 4, right? So if I let u be 1 plus root x, I would get like u to the negative 4, right? Or like 1 over u to the fourth, if you like. And that's easy to integrate, right? So that's the first step. Good. So derivative of 1 is 0. Derivative of root x is what? It's 1 over 2 root x, right? Dx. So again, let's isolate the dx. So dx is 2 root x du over u to the fourth. Okay, I cannot have, if it's du, everything should be u variable. So this is the extra step. So how do I make everything u variable? How do I get rid of that root x? What is root x in terms of u? I mean, look here. Solve for root x. What is root x in terms of u? Good. So before we continue, let's figure out the bounds, right? When x is 0, what is u? Good. When x is 1, what is u? Good. Okay, at this point, right, this is 2u minus 2 over u to the fourth. We could like split this, right? To like 2 over u cubed minus 2 over u to the fourth, right? Wait, hold on. U minus 1. Yeah, u minus 1. Okay. So, okay, now this is easy now, right? So 2, what's antiderivative of u to the negative 3? I think it's u to the negative 2 over negative 2, right? Minus u to the negative 3 over negative 3. Evaluated here. But let's simplify this a bit. So this thing is just negative 1 over u squared. And this thing is plus 2 over u cubed, right? Hold on, take it back. 2 over 3u cubed. Yeah, evaluated at 1 and 2. Whatever this is, right? 1 has 1 over 4 plus 2 over 3 times 8 minus negative 1 plus 2/3. I mean, assuming I didn't make an algebra error. Everyone understand u sub? Yes, no. I mean, for now, right? So later on, you'll learn a lot more methods, right? But for now, I mean, the only methods you learn of solving an integral is just knowing the antiderivative or u sub, right? So for now, like you don't have to worry about should I use u sub, because that's really the only technique you know right now. But later on, it might be not, u sub might not be feasible, and then you might have to use something else. Okay. Since everyone is good on this, let's continue. So area between curves. So this thing, right? Like we have a notion of, okay, in the past, what have we been doing? We have still been doing area between curves before a specific curve, right? So if I ask for area of A and B, right, under F, this is the area between two curves. What are the two curves? It's curve 1 is F. Curve 2 is the x-axis. Yeah, y equals 0. Does everyone agree? Like, I mean, it's the area from A to B between like these two curves, right? Everyone see that? So like you, in this case, right, you would just say this, right? But really it's a difference of two curves. You're subtracting 0, if you like. But like nobody said like why does curve 2 have to be y equals 0, right? You can ask like if I had like two curves like I don't know, like this. This is the top one's F, the bottom one's G, right? Then I could ask for the area between these two, right? Where curve 1 is F of X, curve 2 is G of X. Let's say this is A. Let's not put this at the, let me change it a bit. Let's move the origin. Let's say it's like right here. I don't know. Something like this. Yeah, just to make it more general. So from A to B. Yeah, so I want this region right here. Yeah. Now you could go both ways, right? So how would you find the area of this region? So let's isolate A and B first. Now, can anyone tell me what this part is? What is integral A to B of f of x? What is this area? It's the area under what? Area under f, right? So I'm going to denote this green. So the area under f, since f is the bottom. Okay. Did I make f the bottom one? I did make f the bottom one. Okay, so it's the area under f, right? So it looks like this, right? Everyone agree? Now, can anyone tell? So what is this now? ABG of x dx. This is area under what? Not a trick question. It's area under G, yeah? So it's this part, right? I mean, let me just, and we want the thing in red. So how do we get that? Knowing area under G and area under F. Yeah, it's just, you just subtract, right? So that's sort of why I wrote -0 here. In theory, we've been subtracting this whole time. It's just we've been subtracting 0. But now we say let's shift curve 2 and not make it y equals 0. Then we have to start subtract. I guess in this case, I reverse the role of G and F. Sorry, but yeah, you can sort of see what's happening, right? Like you, to get the area inside, you take the difference, right? Top minus bottom, if you like. Right, so if you like, this is top minus bottom for dx. So right, the G is the top, right? This is the top, G is the top, F is the bottom. Now you could go another way. So let me replicate this picture. So you see here, let me just write it out. What did you do for Riemann sums? You took rectangles, right, like this, right, of width dx, and the height is the difference f g minus f, right? and then you integrate it left to right, right? You integrate left to right, right? Like you start from the left at A, and then you integrate this way to B, right? And then you're taking rectangles like this, right? Now, now we could say, let's do it dy, right? Let's integrate vertically, integrate like bottom to top, right? And that's also doable. So you could, all you have to do is like tilt your head if you like. So this, what was this? This was F, this is G, right? So instead of taking rectangles like this, we take rectangles like this. Yeah. And so here it would be just like we do top minus bottom, right? For the dx, it's right minus left, right? Minus left, or if you like, yeah, right minus left if you like. So this thing would be integral. It would be g of y. No, sorry. The right part is f. So f of y minus g of y dy. But the bounds are different now, right? The bounds, we're integrating bottom to top, right? We integrate bottom to top. So the bottom part is this y value here, whatever the y value is here. And then the top part is whatever the y value is here. Yeah. And this will give you the same answer, right? So like, yeah, so we'll see later on an example of this, right? And you might wonder, why do we care about dy and we could do dx? And the point is, in some cases, it makes stuff easier. Yeah. Is everyone good so far? Does everyone understand the concept before I go into examples? Yes, no. So I guess let me be clear on this, right? So if like f of x was, say, this is you know, y equals, let's say it's y equals x squared, or yeah, x squared, yeah. Then what I mean by f of y is x is, you would have to do x is square root y, right? And then you would take the appropriate one. In this case, it's in the horizontal space, so it's the plus, right? So this would be like f of y, right? You would solve for x in terms of y. And then when I write like f of x, this is just x squared, right? Y equals x squared. And then here x is root y. So that's what I mean by f of y. You solve for x in terms of y, and then, or like, yeah. And then the other one's like y in terms of x. Okay, I'll do an example of that later, but let's start off easy. Where is it? Okay, so I'm gonna do a graph, right? And then you all tell me how to find the area. So this thing starts at 0, goes like this is a parabola. This is y equals 3x minus x squared. So I'm going to trust you can all graph these, right? You have to know how to graph these, but these are pretty basic functions. This is y equals x. And I want you to find the area here. Okay, so let's use dx, right? Not dy, since that's what you're used to. So dx, right? I'm integrating left to right, right? So obviously my starting point is at 0. That's easy. And I integrate all the way to this point right here, right? Now, what is the x value here? Can anyone tell me how to solve for that? So I'm integrating 0 to, I need to find what this is. So for this thing, what is that point? Yeah, it's the point where the two curves intersect, right? Like this thing and this thing. They intersect at this point, right? So that's when they're equal to each other. So we just set it equal to, if y equals x, then x equals 3x minus x squared. So what is that? 0 equals 2x minus x squared. 0 equals x. 2 minus x. So x equals 0, x equals 2, right? X equals 0 is obviously this point, right, where they also intersect. So this point must be the 2, right? So there's integral 0 to 2. And then what's top minus bottom? We're doing dx, right? So it's the top minus the bottom. What is the top function? Good. Minus, what's the bottom? Yeah. I mean, at this point, it's just, you know, how do I say it? At this point, you know what to do, right? But let's just calculate it. What is that? X cubed over 3. 0 and 2. So this is nice, right? Because at 0 is just 0. So it's just at 2. 8 over 3. So that's 4 over 3. Everyone good on that? Okay, so let's continue. Right, so let's just do one more for like example, right? Just so we're all clear. So we have y equals x squared. And then we have the function e to the x. Yeah. So I want the point where the region here. So this is the point where this is the value e. And I want starting at the origin. Yeah. So, and I want this region here. So I'm just testing you. So let's do dx again, right? Since we're more comfortable with dx for now, and then we'll do dy in the next problem. So dx, I'm integrating from 0 to what? Right, I'm integrating from here all the way to this x value here. So what is that? So I know at this x value, the value of e to the x is e. So what should x be? I mean, when I plug in x, I get e. So what should x be? Yeah, should be 1, right? So this is 1. Okay. Now what is, so it's, again, it's top minus bottom, right? So what is the top? You have like 2 functions to choose from. Yeah, e to the x, right? So e to the x minus the bottom is x squared. Agree? Okay. Now this is pretty simple. It's this. So that's e to the 1 is just e minus 1/3 minus 1, right? Because e to the 0 is 1. So your answer is this, right? Okay, is everyone clear on this? We're going to do something very much harder now. But after this example, you will see like if you understand it, you will. I think you can solve like any area question outside of graphing, right? I trust you can all graph. So let's continue. So this thing right here is pretty interesting. So I'm gonna go. This is the line y equals 1, right? This is that y equals 1. This is the line at say y equals -1, right? And then I have a parabola going like this. Yeah. So this thing is given by x equals y squared minus 2, right? So obviously this thing's y equals 1, y equals -1. So this thing, right? And then I'm gonna take a curve here and I'm gonna draw it. This is, this thing is x equals e to the y. Yeah, so I mean, if you like, you can natural log both sides. Y is ln x, right? This is just a graph of natural log. And I want the region here. Like, does everyone like know what the question is? So this is actually very hard if you try to do dx. So let me explain why. At least let me ask you why. So if you do dx, it's top minus bottom. But if we use dx, let's see what we have to do. So I'm going to separate the two. At this x value, this is when y is 0, right? So x equals 0 squared minus 2. So x is -2 here. And where do they intersect the line y equals 1 and y equals -1? So when y equals 1, x is -1, right? So this point is -1. And this point right here, right, is at where? It's when y equals -1. So this is e to the -1. So this thing is 1 over e. Okay. Now, I claim we need 3 integrals if we're going to do dx. And let me just say the issue is it is top minus bottom, but the top slash, let me just say and slash or bottom changes. So let's figure this out, right? From -2 to -1, what is top minus bottom? Like the region here. What's the top minus the bottom? Like, can anyone tell me? Which function am I doing? At least just say like what it looks like. Is it the line, the natural log, or like the parabola? Yeah, it's sort of, but remember we're doing dx, right? So from -2 to -1, to do dx, we need to change everything back to x, right? So if x is y squared minus 2, x plus 2 equals y squared. Y is plus minus root x plus 2. Agree? Now, which one's the plus part? Is it the top part of the parabola or the bottom part of the parabola? Which one's the plus square root of x plus 2? Good. So the top part, right? So the top part is and then the bottom part's the minus, right? So again, it's top minus bottom, right? So it's root x plus 2 minus negative root x plus 2. Yeah, in this case, it's just plus plus. Does everyone agree so far? Like, no issues. Okay, now let's do the from -1 to e now. Right? -1 to e, or 1 over e. What is top minus bottom now? I'm doing from here to here. What is the top and what is the bottom? the top is just 1, right? The function 1. And the bottom is the function minus 1. Agree? Do you all see this? Or, whoa, why am I having eraser? Yeah. So this is, I mean, this would just be integral of 2, right? And finally, I do 1 over e all the way to this point, right? Which is when y equals 1, I mean, if y equals 1, x is e. So this is up to e. So it's 1 over e to e of what? Of this thing here. So what is top minus bottom in this case? So how about I highlight the top and bottom for you for each one. So the top is here. The bottom is here. For the blue part, the top is this thing. Bottom is this thing. Now, what about yellow? What is top minus bottom? Good. Good. The top is just the 1, right? And then the bottom is this thing, which is this, but we have to solve for it, right? Because we're doing dx. So if x is e to the y, ln x is ln e to the y, which is y. So y is ln x. So it's 1 minus ln x. So this will give you the correct answer, provided you solve all of these, right? But you see how much more complicated. But right now, even if you wanted to do it this way, if you're like a masochist, you actually can't do it yet because you haven't learned what an integral of ln x is, right? I mean, if I ask you right now, what's integral of ln x, you probably don't know because you don't know the technique to solve that yet. So you see, dx is much more. I guess the issue is just let me just say longer. I mean, it's still doable. Like the thing I boxed will give you the correct answer. It's just, as you can see, very difficult and long. Okay, so now let's see the beauty of dy, right? So let me just draw the same thing again. So this is y equals 1, y equals -1. And then I have this parabola thing again. Right, and then I have the x equals e to the y. And this thing is x equals y squared minus 2. Okay, so I want this region again, right? Let me just make it green. So I'm doing dy now. So I'm integrating bottom to top. What's the y value at the very bottom right here? What's the y value here? You see, it's much more simpler. So what's the y value here? Like, yeah, -1, right? Good. Now I'm integrating, right, all the way up to here. What's the y value here? Good. Now it's right minus left, right? So what is right minus left? What's the right function? What's the right part? You see, the right part is always this thing, right? So what is it? E to the y, good. Minus the left, and you see in this case, it doesn't split, right? Because we don't need to solve for x. So this parabola is actually like one whole function, right? It doesn't split to like 2 square roots. So the left is just this thing, which is y squared minus 2 dy. And this is this will give you your answer if you solve for it. So minus y squared plus 2 dy. So you see that dy is much easier, right? Because the antiderivative here is y cubed over 3 plus 2y. And you just evaluate, right? So that's e minus a third plus 2 minus 1 over e plus a third minus 2. So it's e minus 1/3 plus 2 minus 1 over e minus 1/3 plus 2. So what is that? That's e minus 1 over e. 2 plus 2 is 4 minus 10 over 3, I think. Yeah, so this is your answer. So you see, like, dy is much easier in this case, right? So make sure, like, so the first thing, like, because when you see a graph, right, is like, which way is easier, right? Like, maybe in later cases, dy will give you 3 integrals, right? So you end up saying dx is probably better, right? So in general, just think of 2 things, right? Dx is top minus bottom. And then for dx, make sure, like, top minus bottom, you're actually, like, you're accounting for what the top is and what the bottom is, right? It's possible it could change, like, as I wrote right here, right? And then same for dy, it's right minus left, and then pay attention, right? What is the right at any point in time, and what is the left at any point in time? Does it change? And once you have those 2 things in mind, like, these questions should be fairly straightforward, right? Because in the end, it's just find balance and then top minus bottom or right minus left. Okay, everyone follow? Okay, so again, you have a quiz on Thursday. So yeah, make sure you study for that. Other than that, I guess I will see you maybe later today in tutoring center. If not, I'll see you all Thursday.